Hello everyone, greetings from Team Malai, a team name which is Malai, which stands for Machine Learning and Artificial Intelligence. We have developed a project named as Motion IQ, and its category lies in mental health and wellness and AML. The problem statement that we're targeting is that we notice that many people struggle to maintain a consistent mental wellness routines like yoga, meditation. Like they face common challenges like lack of real-time guidance, repetitive and unengaging task tracking, absence of personalized feedback, poor form of technique, and low motivation, obviously. And there are multiple features. Okay. And then we have Motion IQ addresses these problems, like it detects the real-time movements and it provides the mental wellness coaching as well. So it encourages mindfulness, correct posture, and it is also giving you a personalized feedback at the end of your exercises. So our overall goal is to enhance the emotional and physical well-being through an integrated tech-assisted approach. Before diving into the code base, let's understand the solution overview more briefly. Just let me show you the ML model that we are working on once. So here is an ML model, and because it is a large model, like you can see, it's a large model. So I'll just explain in short with the help of this file side by side, so as to show you the exact view. Okay. So majorly, like the dependencies that we have in our ML model is that it starts by installing necessary libraries like MediaPipe, Pillow, Matplotlib, NumPy, OpenCV, Python, TDM, and Request. And if you notice that we have pose embeddings, basically pose embeddings is basically to convert the 3D pose landmarks to 3D embeddings, and which is essentially a representation of the pose. Okay, now how it is converting, let's understand this. So here we have pose embedding part. Now it converts the poses to the real time. Like it finds the middle portion. Like for example, I'm telling you in layman language. For example, there are shoulders. So left and right extreme points would be targeted, and a median point would be targeted between those points. And similarly for hips ratio. And then median line would be targeted, and according to that, lines and stray marks would be find out in this. Before this, yeah. So here is the landmarks and embeddings. Now, once the embeddings are created, those are stored in the vector database. And for finding the landmarks, so now, yeah, here is the like how we are finding the indexes. Like for hips, left hip plus left hip, right hip divided by 1/2. This is how the median hip ratio is found, and so on. And torso size is found as if the shoulder minus hip ratio, so as to find the exact upper region of the human body. And similarly, it goes for other body parts as well. Like you may see, like right hand, right ankle, left knee. There is lot. So to understand this, I have made a small, like one pager notepad. So here we have full body poser embedder function, which imposes. I have already explained this. Then we have post sample function. It is a simple data class to hold information about a post sample, name, landmarks, class name, and embeddings. Like a model is already finding this, so we need to also store them, and then we would be comparing it with the existing values, which is already prescribed in data format in the form of CSV format. Then we have post amplifier outlier, which is used to represent pose samples that might be outliers during the validation process. Now, not every pose may be aligning to the defined pose. It may be like extreme or incorrect pose. So we have defined a function for outliers as well. Then we have pose classifier, like how the pose is basically classified. This is the core classification task. It loads pose samples from CSV files, as I'm told that CSV files are loaded, and then these pose embedded to get the embeddings. And then it classifies new poses based on the similarity of their embeddings to the loaded samples using a KNN like approach. And post classifier function is performing over here, like post classification. This is the function which is like it is in getting the values from CSV formats, how many landmarks are there, dimensions are there, and finally the landmarks are being found. And yeah, so let's move to EMAID depth smoothing. Now, basically, we need to smoothen the motions as well. Like it implements exponential moving average to smoothen the post classification, and repetition counter as well. In repetition counter, what we did was we defined two threshold values. Now, not every push-up, like you might have heard about half push-up or complete push-up. So we have defined two thresholds. Once the user crosses higher threshold, then the push-up count actually starts. And when the user approaches means or the least threshold value, then the count decreases, then the count ends and a count is incremented by 1. I'll show you better by this code. So yeah, here we have the code. So there we have defined the threshold values, and it may be somewhere like, because this was like we were working for 3-4 weeks and we have defined almost everything. So I'll tell you from the here only, like it's called a lot. It's called a lot. So this class counts repetition of a specific target pose by tracking when the pose confidence process defined entry and exit thresholds. Now we have pose classifier visualizer. Now it helps visualizing the classification history and repetition count. Now, how this app is actually working is it first builds the classifier. Now, we are also giving you the option to build a classifier of your own if you are having a data set which is having the correct images. So, it involves preparing the training data set. You need to upload basically a zip file which contains folders of images for each post. Basically, in our case, we just embed a small data set because we were not having that much time to explore. So, the notebook then uses Bootstrap helper to process these images, detect poses, save the landmark data to a CSV file, and generate images with the detected landmarks for manual verification. And it also includes steps for automatic outlier detection. Now there are many. And step 2 would obviously be that it classifies the pose, like it's demonstrate how the trained classifier on a video is uploaded. For example, you upload a video, or you can also, we are also thinking of feature in the real time. You can examine the features. Now user could also upload their video, and then they could like target the post for counting, and then the notebook process the video frame by frame. For each frame, like a whole video is there, it would be divided into frames, and those frames would be categorized onto the basis like classifiers being used, like here classifier visualizer, and so on. So let me show you a bit of demo of the code as well. So let me just run the, yeah. So for example, let's say you have something new fitness plans, and then we have this. This is how, like, for example, you select some days and you would be able to implement those plans. And yeah, so these are the exercises and questions that we made it. Like these are the accurate, like you should follow these.